Finally, we're going to look at compound inequalities as well as absolute value inequalities. Our first example is a compound inequality because we see two inequality symbols. There are two different ways to solve this one, so I will demonstrate one of them on part A and I'll show you the other one on part B, and you can choose which version you like. One is to just treat it like a normal equation where whatever you do to one side, you do to all three sides. So if you do something to the middle of the inequality, you have to do it to both the left and the right side as well. Since our x is in the middle, I want to isolate it by adding 1 to all three sides of the inequality, which gives us -2 is less than or equal to 6x, which is less than 4. To finish isolating x, we'll divide all three sides by 6. Simplifying our fraction, we have -1/3 is less than or equal to x, which is less than 2/3. Next, we're going to put this on a number line. Since both of our fractions have 3 as a common denominator, we can split up our number line into thirds. We have a closed circle at -1/3 because of the or equal to, and an open circle at 2/3, and our x is in between those two values. That was method 1. Method 2 is to split it into two different inequalities. We would have -1 is less than 3 minus x all over 2, and 3 minus x all over 2 is less than or equal to 1. When you do this, be careful that the entire middle you use for both of your inequalities. If you had an inequality like the first one, I see a lot of students try and split it in the middle of the expression that's in the center of the inequality. So be very careful that all of that expression needs to go together, and you will go from one end of the inequality all the way up to, but not including, that second inequality when you're splitting it. And then you will solve the two inequalities separately. Here we'll multiply both sides by 2. Since it's a positive, the inequality symbol will not flip. Next, I'll subtract 3 from both sides, leaving me with a -x. Now we will have to either multiply or divide by a -1. When I do that, the inequality symbol needs to flip. Solving my second one again, multiplying by 2, subtracting 3, multiplying by a -1 and flipping that inequality as I do so, I get two inequalities. X is less than 5 and x is greater than 1. Setting up our number line. We have an open circle at 5 and a closed circle at 1. And where is x less than 5 and greater than or equal to 1 would be in between. Last, we'll take a look at absolute value inequalities. We are going to split these into a compound inequality, and the way that we do that is based on what inequality symbol is being used for our absolute value. I have a cheesy little saying to help you remember this, but cheesy sayings tend to stick, so hopefully you will continue to get these right as you work with absolute value inequalities. If the absolute value is greater than that number, you will set up an or inequality. That's what we have here. So we're going to set up x minus 3. When you do this, you drop greater than or equal to 4, or what's inside the absolute value, x minus 3 all over 2, is less than or equal to a -4. So we flip the inequality and make the value negative. The reason we do that is because what's inside the absolute value could be negative. The absolute value will then make it positive. So thinking about values that are negative, but the absolute value would be greater than 4, would be, for example, -5, -6, -7, and so on. All of those values are less than or potentially equal to -4. That would give us the correct absolute value for the inequality we started with. Now we will solve each of these separately, multiplying both sides by 2 and adding 3. Or On the other one, again, multiplying by 2 and adding 3. We have either x must be greater than or equal to 11, or x must be less than or equal to -5. Let's take a look at what an or inequality looks like on a graph. Setting up our number line, we have closed circles at both of them. X is greater than or equal to 11, so we're shading off to the right, and less than or equal to 5, so we're shading off to the left. One last inequality. Take a look at this when the absolute value is on the wrong side of the inequality. So when we're reading this, we need to read it backwards. Remember, it's about where the absolute value is, not how we would read the inequality symbol itself. So our absolute value is less than 1, so we will set up an and compound inequality. 1 is greater than 1 minus 2/3 x. So the first inequality you always set up is just exactly what you started with, drop the absolute values. Now we had a less than, so we're setting up an and inequality. Make the number negative, flip the inequality symbol, and then drop the absolute value again. Solving each of these, if I subtract 1, multiplying by the reciprocal to cancel my fraction, I would multiply both sides by a -3/2. Well, 0 times anything is 0, but I did multiply by a negative, so I have to flip the inequality symbol. For graphing purposes, some of you may find it very helpful to put the x on the left-hand side so that you can read the inequality left to right instead of trying to read it backwards. If you choose to do that, you need to flip everything, including that inequality symbol. Taking a look at our second inequality, same thing, subtracting 1. This time when we multiply by the reciprocal to cancel that -2/3, we will have a little bit of math to do on the left-hand side. Our negatives and our 2's cancel, leaving us with 3. We multiplied by a negative, so we need to flip the inequality symbol. Of course, everything over there cancels except our x. And if you feel like you need to rewrite it so that your thoughts are organized, flip everything. Finally, setting up our graph, this is an and, so we will only shade where they are both true. We have open circles at 0 and 3. X is less than 3 and greater than 0 would be shading in between those two values. And here are your try questions.